Now it's time to start analyzing the performance of the eShop online store. To do this, we will run a longer test than before. First, we will start the analysis with the Grafana graphs. Then, we will connect using the Visual VM profiling tool to the testing object. And then, we will finish the analysis with the Gatling report. Before we begin the analysis, we need to configure the connection in the WinCP program, which will allow us to download files from a remote machine. Copy the IP address of the machine with the generator, set Ubuntu user, and specify the path to the file with the private key. Save it as load generator, performance testing. Connect. Go to the data load generator dist folder. In the future, we will see the test results in this folder. It remains only to run the test and start the analysis. Open the application.conf file and double the duration of the test. And now let's run a scenario for testing a closed system. The test is running, and now we can open graphs in Grafana. We will start the analysis by checking the number of users. There should be 100. Each of the users will make one chain of requests every 10 seconds. Each chain will consist of 10 requests. So we expect a total request rate to be 100 requests per second. We will be ready for this level of load within 5 minutes, so it is necessary to wait a little. For now, you can do the next. Connect to the online store using the Visual VM profiler. Open the program. In order to avoid problems with the profiling, the program must be run with the equal version of the Java virtual machine with which the application build profiling is running. We set up a remote connection and select the web server machine. Now it remains to add the port, which can be viewed in the startup file. GMX remote 5000. Change the display name. We successfully connected to our application. You can immediately see the parameters with which it was launched. And now slowly we can begin to get acquainted with the charts. So we see how the application is using the processor, how memory is being used, how garbage collector is working. How many threads are running in total, how many classes are loaded. We can also see which threads are active. And after that, you can study the call stack and find the method that runs the longest. There is also an opportunity to get acquainted with how much RAM the created objects occupy. Moreover, you can take a snapshot of memory and CPU for further analysis in offline mode. More than 5 minutes have passed, we have reached the load, and on this graph, we see that 100 users have been injected into work as expected. The name of the scenario that was started is also displayed. The first rate graph shows the total rate of requests, 100 requests per second. And on the second graph, there is the duration of the execution of the entire chain of requests. It is approximately 800 milliseconds. You can also see the total number of requests that have been sent at the moment. And there is also statistics for each request. There are 10 types of requests sent to the eShop, and the rate of each is 10 requests per second. Information about the duration of processing of each of the requests is also provided. Same about quantity. A little higher we can choose the status and display only requests that are matched to it. OK, these are successful requests, and KO, these are not successful. As we can see, we don't have a single request that would end it with an error. And also next to it, you can choose what type of duration to display. The 50th percentile, 75, 90, or the average value. Now let's open the hardware resource utilization dashboard. Let's start with the machine with the load generator role. We see that the usage of the resources is minimal. The situation is similar with the machine with the monitoring role. And now let's open the web server. We see that the two CPU cores are loaded by 26%. The cores are loaded evenly. Also, the more detailed statistics on the usage of processor time is provided. Memory usage is at a minimum. Earlier in the profiler, we saw more detailed information. This graph displays metrics only for a machine with a web server. You can see how the size of the database is increasing. And on the last graph, we see that 100 users have actually opened connections and are holding them. Now it remains to wait for the end of the test and look at the report that Gatling will provide. The test is over. We can verify this by looking at the charts as well as the Gatling console output. At the end of the output, the final statistics appeared. Also, a report has generated, which we need to study. Let's download it to the local machine and open it. Go to the folder with the report and download. Open index.html and we see detailed statistics provided by the Gatling framework. There are various statistics, both for requests in general, their rate, duration of processing, how much requests were sent in total, and for each of the requests individually. To do this, open the Details tab. So, now we have learned some information about performance analysis. For example, how to organize monitoring of hardware resource utilization, how to set up the output of load generator statistic to Grafana, how to work with Gatling report, and moreover how to use a profiling tool. Using all this knowledge, we can continue further performance investigation, increase the load, make changes to the application code, repeat tests, achieving better and better performance.